Hello everyone, my name is Jyoti. I'll be talking about our work on off-grid charging infrastructure. So the main question arises here is why off-grid charging systems? As electrical vehicles are day by day increasing so much, henceforth the requirements of on-grid charging systems is also increasing. It is becoming a burden on-grids, and this is especially very concerning during the peak hours, when the grid is already under the stress of regular household and industrial distributions. As per the recent study of the Hindu Business Line, in the first quarter of financial year 2025, the public EV charging stations have consumed almost 176 million units of electricity, which is 108% more than last year's consumption for EVs. So here our project investigates how independent off-grid solar system can help us to distribute load while providing sustainable charging solutions for electric vehicles. So let me just talk about the components we used for our project and the setup. So we used 550 watt solar panel of 13 amps installed in our Atria University's rooftop. Then a 36 volt and 7.5 Ah battery is directly connected to the solar panel, working as the BESS storage. Then we have a power conversion equipment, which is our DC-DC converter of 30 to 36 volt input and 0 to 110 volt and 5 ampere output. Then we have a second battery of 24 volt and 7.5 Ah capacity, working as the electrical vehicle battery load. But before we can start our project, we also had to understand the characteristics of the battery and the solar panel. So henceforth, we conducted multiple charge and discharge tests to analyze battery's behavior. And we also recorded solar panel readings for 7 different days at the interval of 1 hour and found out the maximum power achieved by the solar panel. Now through this project, we aim to show the decentralized power generation and storage can be effective strategy for supporting and growing EV market while maintaining the grid stability. Now further, my friend Jimal will explain you.
Hello everyone, my name is Jimal Doshi. I'm studying in second year e-mobility at Atria University. I'm here to talk about our innovative project that we have done here, a solar powered 9 kW DC fast charger which is designed and fabricated at Atria University. And the whole big problem to solve here is to create an off-grid charger which is totally disconnected from the grid and which can be totally sustainable from solar power. The objective of the project here was to create a universal EV charger to charge electric vehicles from scooters, bicycles to e-rickshaws and electric vehicles. The key challenge that we are solving here is to create a sustainable and an off-grid EV charging infrastructure. As my friend talked about, the prototype that we made as a proof of concept as a small-scale EV charging infrastructure, which was a capacity of 500 watt solar powered EV charging infrastructure. From that, we have scaled up to a 9 kW DC fast charger, which can be very beneficial in our real world application. Talking about the solar panel configuration that we have a solar panel of 550 watt, which can generate about 42 VOC and a current of 13 to 14 amps at peak power. The configuration of solar panel that we have are 9 panels which are connected in series and parallel configuration, and which can generate about 120 volts and it can generate about 42 ampere during the day. With this setup, we estimate energy generation of 30 kilowatt hour during the day. Considering the energy availability, we have designed a lithium-ion battery capacity of 200 ampere hour and 120 volts. Which gives a output of 24 kilowatt hour. The battery management system has certain configurations of upper cutoff voltage at 140 volts, lower cutoff voltage at 100 volts, and discharge maximum current of around 100 ampere and maximum charge current of 50 ampere. The DC bus of the solar panel is connected to the battery storage system, which acts as our primary source of storage in our system. At the heart of our system, we have a DC-DC converter of capacity of 9 kW, which takes an input of 110 volt DC and gives a variable output of 0 to 400 volt DC and 0 to 20 ampere as our output. This system also includes a real-time monitoring of voltage and current, which can be set according to the user and the vehicle which is connected to. There are 2 major project outcomes that comes from this solar charging infrastructure. One is to determine how many EVs can be charged directly from the battery without the solar input and assess the number of hours illumination is required to charge the whole battery. Second outcome of this is to know the cost benefit analysis, to understand the capex of this project and to understand at what revenue can be generated from the tariffs given to electric vehicles to be charged. We have a future development goal to actually implement this into our campus and to charge electric vehicles, also connect a CCS2 connector which has a real-time interface which can communicate with the vehicles and charge accordingly. This project represents a very big step towards EV charging infrastructure. We thank Atria University for their technical and financial support to make this into a reality. A special thanks to Dr. Nagesh for constantly guiding us and taking us to a reality. If you believe in cleaner, sustainable future, join us on this journey and follow us for more innovations that drive us towards sustainability.